everyone, and welcome back. Thanks for joining us. Today, we take a look at one of the renewable energy sources we have on hand thanks to Mother Nature. We're talking about solar energy. It seems fitting as we've now got that glorious sunshine peeking through the clouds. I'm sure you know that solar energy has been around for years, but you might be surprised to learn exactly how many years. The sun's power was first harnessed way back in the 7th century BC to light kindling when focused through a magnifying lens. Since then, people have used the sun in various ways, from cooking to powering engines to providing electricity. Perhaps the biggest breakthrough came in 1839, when a French physicist discovered the photovoltaic effect. 2 metal electrodes placed in an electricity-conducting solution created voltage when in sunlight. The term photovoltaic literally means light electricity. In 1873, selenium was found to be photovoltaic, which proved that light without heat or moving parts could be converted into electricity. Then, in 1884, Charles Fritts placed photovoltaic cells on top of a New York City building to create electricity. The initial fervor surrounding solar electricity started due to concern back in the 1860s that we would soon run out of coal. But then with the arrival of the 20th century, coal was back in abundance and cheaper than ever, so solar experimentation stagnated. The period immediately following World War II saw another resurgence in the need to find alternative power sources, so the development of silicon solar cells in 1953 was a huge moment. It was stated that we were entering a new era, being able to harness the almost limitless energy of the sun to power civilization. The silicon solar cell had 4% efficiency, which compared very nicely to the 1% efficiency gained from selenium. In 1959, 10% efficient, commercially available solar cells were produced. Later, in the 1970s, Exxon funded research that saw the discovery of less expensive solar cells. Most offshore oil rigs used the solar cells to power the warning lights atop the enormous rigs. Between 1970 and 1983, photovoltaic systems grew rapidly, but another drop in the cost of fossil fuels, this time oil, saw yet another stall in the continuing development of commercially available technologies. However, some work carried on, and in 1985, the University of Wales broke the 20% efficiency. And in 1994, the US National Renewable Energy Laboratory developed a solar cell made from gallium indium phosphide and gallium arsenide, which became the first to exceed 30% efficiency. Today, solar panels are available in the form of glass, fabric, roof tiles, and other building materials, and are really quite inexpensive. But they usually operate with an efficiency of between 15 and 20%, although some labs can achieve higher than this, even up to 47%. This isn't the case for commercially available thin photovoltaic cells. Let's get technical and talk about how these photovoltaic cells work. Light is received onto a silicon solar cell. When light, or photons, strike certain compounds, it causes the surface of the material to eject electrons. When light strikes other compounds, it causes the material to accept electrons. It is this recombination activity that causes energy to be released, which is what we capture as electricity. This is sent to an inverter to convert it from the feeble DC electricity to reliable, high-voltage AC electricity. But can this then translate to producing vast amounts of power? It sure can! There are currently enough solar installations in the US to power 5.7 million average American homes. Pretty impressive, right? And once the technology, which is evolving at a rapid rate, can harness and store solar energy more effectively, we will see more and more use of this amazing, infinite energy source. A desert area of 10 by 15 miles could provide 20,000 megawatts of power. That's enough to power 3.5 million average American homes for 1 year. The Office of Energy Efficiency and Renewable Energy, part of the Department of Energy, is hard at work researching solar opportunities and developing tech. They have investment of approximately $179 million for their current portfolio of projects. Some of the exciting new tech in the solar energy space includes solar-powered roads, which will provide clean power for lighting, solar-powered textiles, surpassing wearable solar power like the watches of the 90s. These textile panels can be sewn into things, such as window curtains. Great advancements in efficiency, taking affordable commercial panels over the 20% mark. And researchers at MIT are working on 2 areas of solar: capturing the waste heat emitted from the panels, which would double every solar cell's output, and storing the energy, because as we know, the solar storage batteries currently available are problematic. There's lots going on in this space because solar power is something we really do have an abundance of on Earth. This is a natural, infinite source of power, warmth, and light, which can help to save our planet into irreversible damage from climate change. Thank you so much for joining us, Swarmers. I hope you've learned something new and are having success in moving toward a sustainable lifestyle. We look forward to having you next time. In the meantime, get out there and bask in the growing warmth of the glorious and powerful sun.